Hi student. So today's lecture is on the PN junction diode. So this is part of the electronics chapter in class 12. Okay. So here I'll just briefly describe about what is PN junction diode, and it is having the different application. We are having the forward bias and the reverse bias, and what is the application of forward bias, application of reverse bias. So these are the things will come in different session. So today's session just to understand what is actually PN junction diode. So p-type semiconductor and n-type semiconductors joined together, these two crystal, and we are forming a p-n junction diode. This is the p-type semiconductor. P-type semiconductor means the high concentration of the holes or positive charge. N-type semiconductor is the high concentration of electrons. Means N-type means electron density is high, free electrons. So how N-type semiconductor is prepared by, so it will be calling the extrinsic semiconductor. Intrinsic semiconductor means there is everything is fine, like it is in full balance, like there is nothing like high concentration of electrons or holes. Whenever we are doing some doping, if we are doing with the trivalent atoms, so we'll be getting the n-type semiconductor. If we dope the semiconductor with the pentavalent, we are getting the p-type semiconductor. Okay, now whenever we are attaching the p-type of n-type semiconductor, what is happening? So p-type is having high concentration of holes, and n-type is having high concentration of electrons. When they are joined together, what happens? There is a huge diffusion start playing. So diffusion means there is a different concentration. So electron will try to move from here, and they'll reach the position, and electron will come here. So electron start diffusing from n-type towards p-type. Similarly, the holes will start diffuse from p-type to n-type. Okay. So after certain time, what happened? There will be a depletion layer. So there is a negative layer in the p-type junction, and there is a positive layer in the n-type junction. N-type. Okay. So what happened? A layer is formed, the negative layer and the positive layer, and this caused a potential barrier. And this potential barrier obviously will stop everything, like no charge will able to flow after the time. So it's called the depletion layer or potential barrier. Now we have two options, forward bias and negative, and the reverse bias. So I will describe the forward bias today. In this PN junction, now if we add a terminal, like let me show you, if we add a battery like this in P type, so what will happen? So the plus terminal is joined to the p type, and minus terminal joined to the n type. Okay. So after that, what happen? The p type holes, there will be repulsion, and they will be start moving towards the n type, and the in the negative side, so there will be repulsion between electron and electron. So the electrons are moving towards the p side. So there will be huge recombination of electron and the holes. Recombination will continue until there will be a voltage. So this called forward bias, because the huge number of free electrons and holes start moving, and there will be a current flowing. There will be a current flowing. So this circuit is called the forward bias. Circuit will be like this in a short. So this is a forward bias circuit. Okay. So there will be a current of millivolt level, and this depletion layer, so we need a minimum voltage to crack this depletion layer. So that's called the potential barrier, and that's called the knee voltage. So knee voltage is a voltage, let's say around zero point 0.6 volt. Okay, zero point 0.6 volt or zero point 0.5 volt. So this knee voltage is a minimum voltage required to break the potential barrier. And once you are able to break the potential barrier, what happens? The current will start flow with this PN junction diode. So that's why it is called forward biasing. Okay. And if you see the graph, there is a voltage called knee voltage. If you give more volt greater than knee voltage, the current starts flowing like this. Okay. There will be a shoot of current. Okay? So this is the knee voltage. Okay, so this is very small description about the PN junction diode. I'm repeating once again. P and N, initially when they attach, there will be depletion layer. So negative ions are accumulating here due to diffusion, and the positive holes are coming here. So there is a depletion region formed. Once we add it in the circuit like forward biasing, so P terminal will be added to the plus of the battery, and the N terminal will be added to the negative part of the battery. There will be a current flow happening. So this is called forward biasing, and forward biasing is narrowing down the depletion region. And the other one is the reverse biasing. The next class I will explain what is reverse bias. In reverse bias, we will just opposite the battery so that the depletion region will be more thicker and there will be very less current. Okay, so that's it for today. Please watch my next session, and if you like my session, please subscribe. Okay, thank you.